This video should help you out with how to do the problems when there is acceleration. Now, if you look at the top, I wrote down the possible equations you can have here. And if you notice, it's the same idea as the last video that I just made with the velocity equals change in displacement over change in time. Remember, that delta symbol always means the second one minus the first one, or the final minus the initial. So the equation that you're actually going to use most often in this case is probably this one here, because a lot of times instead of being given just a change in velocity, you'll be given actually two different things and you'll have to solve for something. So what I'm going to do is I'll go through and I'm going to do question number 2 on worksheet 2 and question number 2 on worksheet 4. So this is worksheet 2, number 2, and then later on I'll do worksheet 4, number 2. Both of these are questions where there is acceleration, so you're going to have to use one of these questions. So on worksheet 2, it says, how fast will Albert be traveling if he has an initial velocity of 7 feet per second? So my initial velocity is going to be V1 is 7 feet per second, and it says to the east because velocity gives me a direction, so I'll include it there. And he accelerates for 5 seconds. So that is the entire length of the trip for the 5 seconds. So it doesn't matter what the initial or final is, but from initial to final is 5 seconds. And we also know he's accelerating at 1.7 feet per second east. So that's my acceleration. And because, and this is squared because it's an acceleration. Now, because they're both to the east, I'm just going to call east positive. So when I'm using things in the equation, I'm just going to get values that are all positive and deal with positive numbers. Okay, and I want to know what the final velocity is, so that's V2, in feet per second. So if we look, first thing, all the units match up. They're all either in feet or seconds or some variation of that. So I can go straight into the equation. Now look at which equation I have. I have acceleration, I have V1, V2, and delta t. So I'm just going to use this one. If you always want to start here and then expand what you need to, that's fine as well. So either way you want to do it, it's okay. But I'm just going to start with A equals V2 minus V1 over delta t. But you should be starting with one of these 4 equations every time and then doing the algebra from there. Okay, you could start with this one every single time and expand what you need to, and that's fine. So I need to solve for V2. So what I'm going to do is I'm going to multiply by delta t on both sides. So delta t times A equals V2 minus V1. And then I'm going to add both sides. I'm going to add V1, so those will cancel out. Add V1 here. If you don't need to write out the steps and you just see it and you can go through and do it, that's fine. But just write out the process of what you're doing as you go through it. And you should end up with V2 equals V1 plus delta t times A. Okay, so I have that as my equation. So I did my algebra and I solved for this variable. Now I can just plug it straight in. So V2 equals 7 feet per second plus my delta t, which is 5 seconds, times A, which is 1.7 feet per second squared. So when I do that, 7 plus 5 times 1.7 is going to be 15.5 feet per second, okay? And if you check the answer on that, that is the exact answer that I got. Again, if you're slightly off, that's okay. Be careful when you're plugging full things into your calculator. If the order of operations will matter, make sure that you put parentheses in it or break it up into multiple steps. So in this case, you can plug it straight in, you'll get that answer and it'll be fine. All right, worksheet 4, number 2. So when we look at this, again, it's just an acceleration question, but there's more stuff to pay attention to. You gotta think about what you're doing. What we have is that there's a car driving at 90 miles per hour. So V1 is 90 miles per hour. Okay, and the speed limit is 65 miles per hour. Now notice it says there's a velocity of 65 miles per hour, but again, just like in the last video, this is just something to compare to at the end. At no point is this person necessarily going 65 miles per hour, so that can't be V1 or V2. So we're just gonna keep reading ahead. If you keep reading ahead, it tells you the acceleration is -6. So A is -6 meters per second squared. And the time, which is the total time it takes, is going to be 3 seconds. And what you want to know is after those 3 seconds with that acceleration, is your velocity under 65 miles per hour? So what I'm trying to find is going to be V2, and I'm going to need it in miles per hour to go through and find my final answer. Okay. First thing it tells you to do is draw a motion diagram. So what I want you to think about is just that it's slowing down, so your dots should be farther apart and then get close together like that. That's all you need for the motion diagram. All right, now, as you look at these actual values here, the units don't match up. This is in seconds, meters per second squared. I don't like to change my acceleration just because I don't want to deal with the squared thing on the bottom. So what I'm going to do, and even if I did change that, I'd have to change the seconds to hours as well to make it match there. So I'm going to change this 90 miles per hour, and I'm going to change it to meters per second. Okay, so the first thing, change miles to meters. And there are 1,609 meters in 1 mile. And I'm going to change hours to seconds. There is 1 hour in 3,600 seconds. So when I get this, I end up with 90 times 1609 divided by 3,600. And I get 40.23 meters per second. Okay, because my miles canceled, my hours canceled, meters per second. Now, once all my units match, okay, because again, this is 40.23 meters per second, now I can go into the equation. Again, I have a V1, I have a V2, and I have an A in delta T. So I'm going to use that same equation as before. A equals V2 minus V1 divided by delta T. Okay, multiply by delta T on both sides, and I get A times delta T equals V2 minus V1. Add V1 to both sides, and I end up with the equation V2 equals, just like up above, V1 plus delta T times A. So I can go through and plug that in. So V2 equals my 40.23 meters per second plus 3 seconds times a -6 meters per second squared. So my second velocity is going to end up being 22.23 meters per second. So that's the velocity of the car. But that doesn't help us in the case of knowing if you were speeding or not when you're going past the cop, because we have to go back and compare it to 65 miles per hour. So what I'm going to do is I'm going to take that 22.23 meters per second and do the exact opposite conversion that I just did. So 1609 meters in 1 mile, 3,600 seconds in 1 hour. So I'm going to take 22.23 times 3,600 divided by 1609, and I get an answer of my final velocity, V2, is going to be equal to 49.74 meters per second squared. So is he going above the speed limit when he passes the cop? No, this is below 65, so he was not speeding. So as was the car above the speed limit? No, the car was not above the speed limit.